Another example on binary operation. Let S be the set contain the element 0, 1, 2, 3, 4 be the set of the set of residue classes modulo 5. Define star is equal to addition in a set S as the addition modulo 5. Then we write the addition on the set S residue classes modulo 5 by table on the set S is under, that is 0, 1, 2, 3, 4 are the elements of the set S, and 0, 1, 2, 3, 4 are the same element of the set S. Add the element 0 with each element of the set S, where 0 is an element of the set S, and 0, 1, 2, 3, 4 are also the element of the set S. 0 plus 0 is equal to 0. 0 plus 0 is equal to 0. This result is less than 5. Therefore, we write the result of the addition of 0 with 0. The result is equal to 0. And add 0 with 1. 0 plus 1 is equal to 1, which this element is less than 5. Therefore, when we add 0 with 1, the result is equal to 1. And 0 plus 2 is equal to 0 plus 2 is equal to 2. This result 0 plus 2 is equal to 2. This result is less than 5. We write it here, this 2 here, and 0 plus 3. 0 plus 3 is equal to 3, and 0 is an element. 0 and 3 are the elements of the set S, and the addition of 0 with 3, the result is equal to 3, which is less than 5. This result, we write this result here, and 0 plus 0 is an element of the set S, and 4 is again an element of the set S. 0 plus 4 is equal to 4. This result is less than 5. We write the result of 0 plus 4 is equal to 4. Similarly, 1 is an element of the set S, and add 1 with each element of the set S. 1 plus 1 plus 0. 1 plus 0 is equal to 1. The result is less than 5. We write it here. This result 0 plus 1. 0 plus 1. 1 plus 1. 1 plus 1. The result is equal to 2, which is less than 5. 1 plus 2. 1 plus 2. The result is equal to 3, which is less than 3. 0, this element 1 is an element of the set S, and 2 is an element of the set S. The result is equal to 3, which is less than 5. We write it here. 1 plus 3. 1 plus 3, the result is equal to 4. 1 is an element of the set S, and 3 is again an element of the set S. The result is equal to 4, which is less than 5. We write it here, the result. And 1 plus 4, the result is equal to 5. 1 is an element of the set S, and 4 is again an element of the set S. The result is equal to 5, which is equal to 5. Therefore, we divide according to the residue classes modulo 5, we divide this result. This result is 5. We divide this result by 5. 5 multiplied by 1 is equal to 5. The result is equal to 0. We write here the remainder when we divide this result by 5. The remainder is equal to 0. And similarly, this 2 is an element of the set S. Add 2 with each element of the set S. 0, 1, 2, 3, 4 are the element of the set S. 2 plus 0 is equal to 2, which is less than 5. We write it here. 2 plus 1 is equal to 3. The result is less than 5. We write it here. 2 plus 2, the result is equal to 4, which is less than 5. We write it this result here. And 2 plus 3 is equal to 5, which is equal to 5. Therefore, we divide this result. This result is 5. We divide this result 5 by this 5. This 5. The remainder is equal to 0. We write here the remainder. This element 0, and 2 plus 4 is equal to 6, which is greater than 5. Therefore, we divide this result 6 by 5. This element 5, the remainder is equal to 1. Therefore, when we add 2 with the 4, we write here the remainder, which is equal to 1. And similarly, this is an element of the set S, and add this element of the set S with each element of the set S. Therefore 3 plus 0 is 3 plus 0 is equal to 3, which is less than 5. We write here, and 3 plus 1, the result is equal to 4, which is less than 5. Therefore we write the result 4 here. 3 plus 2 is equal to 3 plus 2, 3 plus 2 is equal to 5, which is equal to 5. Therefore we divide 5, this result 5 by 5, the remainder is equal to 0. Therefore we write the remainder, which is when we add 3 with 2, we write here the remainder 0 as explained above, and 3 plus 3 is equal to 6, which is greater than 5. We divide this result 6 by the element 5, the remainder is equal to 1. Therefore we write here the remainder when we add 3 with 3, and 3 plus 4 is equal to 7. 3 which is greater than 5, we divide 7 by 5, the remainder is equal to 2. Therefore when we add 3 with 4, we write here the remainder, which is equal to 2, as 7 is greater than 5, as according to the residue classes modulo 5, and so on. Similarly, the last element 4, which is an element of the set S, add this element 4 with each element of the set S. We have 4 plus 0 is equal to 4, which is less than 5. We write it here. This result, we write this result which is equal to 4, and 4 plus 1 which is equal to 5, which is equal to 5. Therefore we divide this result 5 by the element 5, the remainder is equal to 0. We write here the remainder, and 4 plus 2 is equal to 6. This result is greater than 5. Therefore we divide this result by 5, the remainder is equal to 1. Therefore when we add 4 with 2, we write here the remainder, which is equal to 1, and 4 plus 3 is equal to 7, which is greater than 5. Therefore we divide 7 by 5, this element 5, the remainder is 2. Therefore when we add 4 with 3, we write here the result is 7, which is greater than 5. Therefore we according to this rule, we write the remainder here, which is equal to 2, and 4 plus 4, which is equal to 8. This element is greater than 5. We divide 8 by 5, the remainder is 3. Therefore we here, when we add 4 with 4 according to the residue classes modulo 5, this result is greater than 5. Therefore we write here the remainder, which is equal to 3. Now each of these elements, as each element of the table after residue classes modulo 5 is an element, these all are the element of the set S. Again, these all of these results is again an element of the set S. Therefore we can say that the star is equal to addition is a binary operation on the set S under the residue classes modulo 5.